Hello, everyone. Welcome to our session on end-to-end AI app development, prompt engineering to LLMOps. My name is Jithendra Veeramachaneni. I have pleasure of leading amazing engineering team that builds the AI platform capabilities at Microsoft. We all have seen how AI is transforming businesses, whether it's much more intelligent customer experiences or new kinds of class of products that have been launched over the past few years. But really, over the last year or so, the pace of innovation is rapidly increasing, and this is all powered by the large language models. ChatGPT is a great example of this, and the trend is only accelerating. Yet, when we talk to our customers, and especially developers, both internal and external, we hear some messages repeatedly that development of these applications is hard. Figuring out this AI quality is good is hard. And how do you figure out how to scale these applications and deploy them is hard. So you need, given how powerful these models are, yet how difficult it is to harness the full power of it, we need a new platform. We need a new way of thinking about these kind of applications. And that's what we refer to as LLMOps. And LLMOps are actually somewhat similar to regular traditional MLOps, but they're distinctly different as well. And at the core of it is the LLMOps or LLM applications are dealing with open-ended problems. They're dealing with data that they've never seen in the past. They're dealing with the questions that they've never seen in the past, unlike traditional ML applications. And that requires a different way of thinking about it. Your building blocks are fundamentally different. You have these large language models that are the building blocks. Then you need to think about how do I get most out of these models by prompt engineering? And then how do I make sure these models are grounded in the data that is most relevant to the customer's question and the data that we have in our systems? And of course, this is a team sport. You still need to make sure that the application conception and ideation, and eventually, once the quality is good, deployment is done through multiple sets of experts in the company, whether it's subject domain experts, or data scientists, or developers, and administrators all working together to scale your application. This is exactly the set of problems we try to set out to do. And first thing to note about this new class of applications is there are three distinct stages, somewhat similar to MLOps, but different in the activities that you do in these stages. The first stage is ideation/exploration. This is where you go to a catalog and pick a large language model. We have access to large language models from OpenAI, open source, and models such as Llama. We have a catalog that has thousands of models that you can start with. And once you have these models, then you need to do prompt engineering to see if the idea or the hypothesis has promise. And once you do, you graduate to the next stage. And then you spend a lot of time, your energy making sure the quality of the application is right. And eventually, you operationalize the model. And all of that is through a management fabric and set of tools that you're already familiar with. It's a consistent CI/CD tools that you've been using in your company, or network and enterprise security settings that you've been using in your traditional application and ML applications as well. So it's important to make sure that you keep that in mind, the full life cycle in mind as you develop your AI applications. Now let's take a look at these three stages into a bit more detail. The first stage is ideation. This is where you pick a model from the catalog, and you think about the data sources that you think can actually help with developing this generative AI application. And think about how do you do prompt engineering to make sure that the responses are in tune with the questions that are being asked. And if the idea holds promise, you graduate to the next stage. Of course, these stages are not linear. It's very much an iterative process. Sometimes you go back and forth. And the second stage is where actually the bulk of the application development, AI application development is. This is where you think about what data sources do I have? How do I actually craft my prompts? And you think about, how do I vectorize my data? What kind of chunking should I use? And should you actually just go back and fine-tune some of the models that we have in the catalog? The most important thing in this of developing AI application is making sure that the AI application has high quality. And evaluation is very, very core to it. If you do a lot of evaluation, then do some more evaluation. And once you do more evaluation, do even more evaluation. If there's only one thing you take away from this talk, that evaluation is very, very core to success of generative AI application. And once you're done with evaluating the application, you're ready to hand off to the next stage, which is operationalization. In the operationalization, it's generally you think about traditional things around, like how do I deploy this application? How do you make sure it is secure? How do you make sure data is protected? But there are additional things to think about when you think about generative AI application. How do I make sure that the application stays in the safety boundaries you expect it to? Whether it's content safety, other, handling things that are inappropriate for the model, how do you filter them out? So there are additional things to think about. Of course, the model is not going to be perfect because it's a probabilistic application, so you need good monitoring ability so you can look at what's working well and what's not working well, so you can go back to the earlier stage and continually improve the quality. And at Microsoft, we've been working closely with our internal teams building Microsoft Copilots, as well as external customers building LLM applications. And through that, we've taken a step back from the requests we've been getting and decided to build an integrated AI platform that covers all parts of LLMOps. We're starting from all the way from a model catalog, which has thousands of models, including OpenAI, ChatGPT models, to open source models, and of course, models like Llama. And once you have the model, then you got to think about how do you vectorize your data, how do you make sure that the most relevant data in your data estate is presented as input into the models, so that responses are appropriate and most accurate. And so you need a vector database for that. And once you have that, then you end up prompt engineering a lot to see what works and what doesn't. And these are capabilities we built directly into our platform. And not just we built the prompt engineering capabilities, which based on a feature called prompt flow, but we built metrics for evaluation as well. We see a lot of common metrics for making sure the model is answering questions that's grounded in the data, that's actually coherent in its response. So we have a lot of capabilities to not just bring you data sources, connect to vector databases, and do engineering around what prompts work and what don't, but also to make sure the responses are actually grounded in the data you want it to be grounded. And once you have that, we built content safety directly into the platform because we want to make sure that all the generative AI applications built on Azure have content safety directly in the platform, so you can filter out inappropriate questions, inappropriate responses that are being generated. And finally, for generative AI application, monitoring is very, very important. And we're all familiar with system-level monitoring, which we do. And of course, we also do application-level monitoring as well. So you can actually see how this generative AI application is doing in real world. And it's not just, and all of Microsoft Copilots are built on our generative AI platform, Azure AI platform. And it's not just Microsoft that's reaping the benefits of the platform investments we've been making. I'm very happy to share that external companies are leveraging Azure AI platform to get to real-world applications with delivering high business value using the AI platform we built. Siemens is a great example of this. Siemens is using our Azure AI platform, in particular our prompt flow features and others for prompt engineering. They built a Team Center application. And the Team Center application allows them to bring their employees from various locations using different languages in real time, communicate with using natural language interfaces. This helps them improve their communications greatly. And so far, this is a lot of talk about slides, what we've been building. What we'd love to show is how these capabilities built, that all the way from the beginning about ideation to operationalization through a real-world example, how this integrated platform really makes it very seamless to move from one stage to another, sometimes forward, sometimes backward, in a seamless manner. For that, I'd love to welcome Cassie and Daniel onto the stage to show through a real example.
Hello.
Hey, I am Cassie Breviu. I'm a senior technical program manager here at Microsoft. But what I really like to explain what I do is just that I build things and then I talk about it to awesome people like you.
Yeah, I'm Daniel Schneider. I'm a data scientist in the Azure machine learning team. Yeah, I like that description.
Yeah.
You build things. I also build things.
We build things.
From time to time, talk about it.
I'm guessing other people here build things too. OK, so we're going to be showing you how to build an app end to end here. And we're going to be starting in AI Studio. The scenario that we're going to be looking at is something with Contoso Trek, which you may have seen if you've been hanging out with this Ignite. And you've probably sat on the keynote stage yesterday. But unlike Seth, I'm going to keep my shoes on for this presentation. So we're going to look at how we can build a support agent to support this Contoso Trek company. So I'm going to get started with AI Studio. OK, great. And here we have lots of great features in order to start building out your applications. We also have the amazing model catalog, which if you click into that, you can see the different models, and then you can also try them out. So you can go ahead and try different scenarios that you have to see if the model will work for yours. I want to know what the meaning of life is according to the Hitchhiker's Guide to the Galaxy. Let's See if it can tell me. Awesome. OK, so this one's going to work for my scenario out of the box. Now, if you hit deploy, it will create an endpoint for you, and then you can start using it in your application. So here you can see different endpoints that I've already created that I'm going to use in my prompt flow. So now that we've seen how we set some of these things up, let's switch over to VS Code. So in VS Code, I have an extension for prompt flow that gives me the tooling that I need. If you take a look at the connections on the left here, you can see that I've already created some of them. I have one for the OpenAI. I have one for the Azure OpenAI connection, and then I also have one for Contoso Search, which is my AI search connection. And then I have my Cosmos database to look up customer information. If I take a look at this connection and how they're set up, you can see it's actually pretty simple. I have an endpoint that I've created in Azure. I give it a name, and then I also have an API key that I've added that is stored in a local encrypted database. I can also set up a JSON file, which connects to my connections in the cloud if I don't want to set them up locally. So once you've set up your connection and you have that ready, you can go over to the File Explorer. In here, if I right-click on the empty folder that I've created, I can create new flow in this directory, and then I'm going to choose the chat flow template. So here we have the YAML that has all the tooling for this template. If you take a look up here, I already have created my Conda environment, so it has the prompt flow and everything installed that I need. And because of that, I can just go ahead and click on the visual editor, and then I get this nice UI where I can play around and create my prompt flows. If I go ahead and click on the chat here, I can select my OpenAI connection. And then from here, I'm going to choose GPT-3.5 Turbo. And then I'm ready to run it. When I click run, it's going to give me two options. I can do an interactive chat, or I can do a standard flow. I'm going to go ahead and choose interactive mode.
And what you're getting here now is really a ChatGPT built-in prompt flow now, right?
Exactly.
You just get the vanilla model, nothing special about it. Right?
Yep, and then I've set up my connection so it knows which one to use.
Yeah.
I'm going to go ahead and ask it the meaning of life again. And there you go. So interactive mode, I can ask a question, and it's going to give me my answer. Now, this is great, but we probably want to build something a little bit more complex than this. We need a lot more features to add to our prompt flow. So I'm going to go ahead and delete this one out. And I'm going to start adding my tooling. So if you take a look over here, there's different tooling that we have in order to create our prompt flow. The first one I'm going to add is the customer lookup. This is going to be a Python file, and I've already wrote the code, so I'm going to jump over to my file and select it. Amazing. So now I'm going to go ahead and add another input. It's going to be the customer ID, and then I'm going to put a default in there. Then I can go to the tool that I've created. From there, I'm going to go ahead and select that customer ID as the input, and then I'm going to choose my Cosmos database, which has my customer information that I want to add. The next tool I want to add is an embedding, because we're going to be using a vector database, and we need to embed our question. So I'm going to call this question embedding. Awesome. OK. So from there, I'm going to connect my Azure OpenAI connection again. I'm going to choose the ADA model. And then I'm going to choose the input as the question. So great. You can see how we can start building these out super quick using the tools that are built in. We also have custom tooling, so you can add all kind of reusable tools that you want to use, including things like if you're doing things with LangChain or semantic kernel. Because these take a little bit of time to build out, I'm going to go ahead and switch over to one that I've built out completely. This is the RAG flow. Now, I think people have probably heard about RAG already, don't you?
Yeah, it was kind of mentioned in like pretty much every keynote and every other talk, but still we don't assume that everybody actually knows the details, and kind of things go a little bit complicated. And so I have a slide for that.
Amazing.
Yes, so we just wanted to give a quick refresher, give us 1 minute, right? So, but RAG means retrieval augmented generation. The problem is the models, like these big models, they do not know your content, like the product catalog that we're trying to kind of bring up here. And so how do you teach the model those that information? And that's where RAG comes in. We're actually going to inject it. We're going to look it up, retrieve, and then inject it. So the way it works is you there's a question. We're going to go to our retrieval component here, and the retrieval is first going to embed that query, which is kind of that embedding node that we just saw, and that is going to return a vector. What's the vector again?
It's a bunch of numbers, really.
It's a bunch of numbers.
In 3D space.
Yeah. But it has the property that things that are kind of have the similar or same meaning will end up very close in that vector space together. So that's what the search index is going to benefit from then. And then we're going to send that vector and that query, so the string as well, to the search index, cognitive search index in this case, so it can do its hybrid magic to basically do like vector search and combine it with keyword search and do some awesome ranking on top of it. And then we get some search results back, and then those search results travel back to our app, and that's the R part, the retrieval. And then we're going to augment that one. We're going to basically augment our prompt with that knowledge that we got from the search results and go to ChatGPT, to the actual chat model. And then that chat model is going to give us a response back, which is then the G, so the R, A, and G in RAG. And then we'll return the answer to our customer.
Amazing. Thank you. Such a great explanation. OK, so now we understand what's happening in our prompt flow. So let's take a look at the one that we've created. So you saw me create the question embedding and the customer lookup. The next thing we're going to do is retrieve documents from Azure Search by sending that vector embedding in. And from there, we can click right into the Python file itself. And the great thing about the prompt flow code first experience is I get all of my amazing tooling that I have in VS Code, so I can set breakpoints and debug the way that I want to build. So if we keep going, we get that documentation, and then we're ready to create our prompt. If I click into the Jinja file here, you can see that we have given our model a task. So the task is you are a support agent, and your job is to solve issues and answer questions according to previous orders. And then in here, you're going to see that we have some safety information, which is important. It's going to make sure that it doesn't answer questions we don't want it to. It's going to make sure that it's using relevant information when it's answering questions. And then we're going to send in the documentation. So this is the documents that we're getting back that's going to give it the information that it needs in order to answer the questions. From there, we're going to give it the orders and then the customer name information. So that's how we are constructing our prompt and getting all that information ready to send to our LLM. If we take a look at the LLM call, you can see that we are just calling OpenAI and getting back that result. Now you can ignore the context here for now. That's something for evaluations, which we'll show you later. So I'm going to go ahead and click run. And then this time I'm going to run it in standard mode because I have added a default question into my prompt. So now this is going to execute the full thing. And then we'll be able to see the result for the question, which is what was in my last order. Great. So once we see that it's executed, we can take a look at these prompt flow tooling down here. If we expand these, we can get more information about exactly what was input and the output.
Lots of floats there.
Yes.
That's the embedding.
That's what the embedding looks like. And then here we're going to get the prompt, and then we can see the LLM call. So if we go and open up this, we can also see exactly what we sent. Make this a little bit bigger. What we sent in. And then we can also see what we got back. Cool. So now we've validated that the basics of our RAG prompt flow are working correctly. We should just deploy it, right? Nobody needs to test it.
Well, let's take a look at the.
Oh, that's right. We have instructions.
We got from Jithendra. OK, so I'm not supposed to look back. OK, it's right in front of me. So I think we went through part one, which is the ideation, exploring. And now we would like to put the prompt flow that you've created through some more rigorous testing and evaluation. So for that, we're going to use a little tool that I built. It's just helping us to kind of be more interactive in testing an app here. And why don't we get started? Since we know that the model is supposed to, or the prompt flow is supposed to know about who I am,
yep.
Like we got some customer information, also what we ordered, that was all coming from the customer lookup, and then we have the product information. So all those three things, let's kind of do a little bit of like eyeballing it. Yep. So let's start with who am I? So see if we had some demo glitches, but today looks like we're looking good. So it says I'm Jason Brown. So the question is that actually a correct answer? I could just have made it up. So we can drill a little bit deeper here, and we can see what the information was that the LLM was actually given in order to kind of come up with that conclusion or with that answer. And we can see, yeah, it's indeed JSON Brown. So that is the right answer. So we're happy with that one. And then we can say, what were my orders? Yeah, and here I get a list of orders. And again, looks like it's plausible, but is it also correct? And we can see here again in the customer data section, we see that indeed like hiking pants, backpack, Adventure Pro backpack, and cozy night sleeping bag is what Jason had ordered. Last question is like, does it know about products? Like, let me kind of copy this and say, what is the temperature rating of the cozy night sleeping bag? And again, it's coming back with something that looks good, and we can also check it now. In this case, now we have to kind of find the documents that were retrieved from the search, you know, the whole kind of thing with the vector search and all of that. We find those here in the citation section, and we can see, okay, there's a cozy night sleeping bag that was actually retrieved, so that's good. It's found the right document. It also actually gave us the right number. It's 2260 Fahrenheit. So yes, I think we're quite happy with this. What do you think?
I think it's doing pretty good, but I think we should make it a little bit harder. And let's not tell it the name of the sleeping bag. I just want to know, it should know my orders, so it should know what sleeping bag I have. So ask it what the temperature rating is of my sleeping bag.
Temperature rating of my sleeping bag. And the assumption here is, sleeping bag, please. And the assumption here is, obviously, the model knows what I've ordered, and so it should be able to kind of go look it up and find it, right? Okay.
It's a little vague. And also, I'm from Minnesota, spring, summer, and fall. That is a very wide range of temperatures. If I go camping, I need to know what the temperature rating is.
Yeah, so, and reliable, it's a reliable. What's wrong with that? But yeah, there's something wrong here, obviously. So again, we can dig a little deeper here and go and find out. Looking at the citations now, we see that it actually didn't find the right sleeping bag. It found Mountain Dream and Mountain Dream, including the temperature rating, so that was found, but it didn't find the cozy night sleeping bag. So this one's mountain, not cozy. And so, yeah. Yeah?
I was going to say, that's a lot of work, right, to be continuing asking the question, jumping into the metrics. Is there maybe an easier way to kind of get some information about that?
Yes, there is. We can use ChatGPT, or in that case, actually, we're using GPT-4 to help us do exactly what I did now 3-4 times, is look at the answer and check it against the context of the reply. So we've actually built this into this tool here. Well, actually, no, first let's talk about metrics in more general terms, because that groundedness is not the only metric that we have. Groundedness, as we define it here, and as you've seen, this basically measures how well the model's generated answers align with the information from the input source, right? And since we look up data, we want to make sure that that data is, of course, the right data. That's one thing, but assuming it's the right data, the model should use it, right? So that's groundedness. Then there's relevance as well, which is, does the model actually answer my question, right? So we can also have GPT-4 evaluate whether that answer that was produced actually relates to the question that was given and is a good answer, right? And then we have coherence here, which is a measure of how well the language flows between the questions and the answers and so on. So okay, so with that knowledge equipped, let's run this eval command here in our little tool. And what we can see is that groundedness is abysmal, 1 out of 5. So it's like the lowest score you can get.
Yeah.
And that's kind of reassuring, because it was not a good answer. It was actually not even a correct answer, and it was certainly not a grounded answer, because there's different information was in the context. And so a bad score is what we were hoping for, right? Also, the relevance isn't really very awesome, 3 out of 5. And that is also correct, because we were actually asking for a concrete rating, and what we got was reliable rating, so kind of evasive language, I would say. Right?
So this is super cool because now we didn't have to dig into everything. We can get a quick snapshot of exactly how that particular question was performing. But I have to ask, what is this tool that you are using?
Yes, let me show you. And the tool is really, it's not a lot of code. But we built it using this little library called Chainlit. And it's kind of nice to see how you can build your own tools here very quickly. It's got like these different commands here, but what it really does is kind of loop your information through to the model. And so let me just show you how easy the eval is. So you can see like if I type config or eval or blah, 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 I get like different functions that get called. And the eval function is a good example of how you just call a prompt flow. So remember, this is a prompt flow, and that prompt flow is defined in this folder that Cassie is there. Evaluation is actually also defined in a prompt flow, as you see, and all we're doing here is we're instantiating the prompt flow client library. So if you pip install prompt flow, you get that on your Python environment, and then you can install, invoke this Python, the prompt flow client with just calling test. Right? Test and then the input. This looks a little awkward because this framework here is async, and so you got this await, and it's kind of needs to make it async and so on. But at the end of the day, it's just basically calling the function test with the input as the dictionary, right? And that way, I can run this evaluation. So let's maybe do like for comparison. Let's look at the question we had before, where we actually explicitly we're naming the sleeping bag by giving it like its proper name, and see if our function here is also giving us a good. In this case, we're expecting a 5 because the answer was good, right? So yeah. So okay. So that's kind of the work we have cut out for us now, right? We need to do something about this.
And this is still cool, and this is still faster than jumping into all the citations. So now we've gotten a little bit faster. But how do we batch this? Like, how do we do groups of testing so that we can do, real performance understanding of how our model's doing?
Yeah, exactly. So it's nice to be able to do this interactively because you can try out. You actually can make some changes to your prompt flow. It's immediately reloading, and you can kind of run stuff here, but it's still one-off, right? And we want to kind of get a bigger picture here. So we do have a test set here, test data. In this case, we only have like 18 questions, but they're all revolve around the problem of this thing doesn't seem to know, it doesn't seem to be fetching the right data, and so it's kind of getting kind of tripped up. And so these are the questions we have, and if I want to run this in a batch, I have a script here that basically runs this as an evaluation. If you look at the script, it's basically using PF Azure, which is a CLI that we have that comes with the prompt flow, so that you can actually kick a job to the cloud. So, and now that job is the evaluation job is running. It takes a minute or two, but we already ran this before. And so I can show you here the baseline evaluation, because we still haven't made any changes to the prompt flow. We haven't even started fixing anything. We're just measuring right now, right? So, so here's the evaluation. It's loading. Yeah.
There we go.
Awesome. And you can see some nice graphs here that tell us like the groundedness rating, relevance rating across our test set here. You can see that the average value is 3.47, and for each value you can see each row in my test set, I can see what the individual values were across these 4 different metrics that we're measuring here. For example, groundedness, where's the temperature rating of my sleeping bag, is a 1. That's what we saw in our manual testing as well. And then it was a 5 for when we were actually asking the question with the name of a sleeping bag in the question, right?
Awesome.
So, yeah, so now we have established a baseline.
Cool. And so when we were running the evaluations locally, did we show them how we actually set those up?
No, we didn't.
We should show them.
Yes, we should show that. Thank you for, good. Okay, so how do these actually work? Like, what is an evaluation? I kind of briefly said it's also just a prompt flow. So there's another prompt flow in my project here, which is called eval flow. And yeah, it's just another prompt flow. You can actually see the graph here is a little bit busy because it's got more, yeah, it's got like a few more nodes, but it is another prompt flow. And if you want to know, like, okay, how does groundedness work, for example, then it's really just like it's like usually it's like basically one node that does it work, which is then actually powered by this Ginger template. So again, we're looking at groundedness. And so here we're giving the model instructions, GPT-4 in this case. You're an AI assistant, and you'll be given definition of an evaluation metric. And then it said, you will be presented with a conversation history, a question, a context, and an answer about that context. And you need to decide whether it's a good answer or not. And then it gives you examples like, or like, give it a 5 if the answer follows logically from the information contained in the context and the conversation history, or a 1 if it's logically false, right? So, and that's kind of, obviously you basically tell that thing what you want out of it, and it'll go and do its best to kind of do that. And usually it's doing a better job if you give it examples, rather than just explaining. There's actually much better job at if you give examples. It's called few-shot. It's a pattern we use all over the place. And in this case, we give it 4 examples. Like, okay, assuming somebody asks that kind of question, that's the context, that's the answer, that would be an example 1, right? And it also kind of steers the model in the direction that it should only give like a number, and not explain like, oh, this is a 5 value, it's a nice blah, blah, blah. So don't get wordy here. Like, just give us a number and be done, right? That helps with performance too, by the way. Okay, and so here we then actually injecting in the template the actual data, and then we run it and get the value back.
So I love this. I think it's so cool that we can use GPT-4 to test our model without having to give it ground truth. Like, we don't have it examples and then also tell it what it should know. We can actually use GPT-4 in this prompt in order to get information without adding grounded truth and all of the extra work that you'd have to do in order to get that information and get that score.
Yeah, and that is what will also enable us to actually measure this kind of metric in production. Because in your production environment, when people are asking your bot questions, you don't know what the right answer is, so you can measure like the result that the bot gave against the ground truth. But this thing actually allows you to still get a measurement of the quality of your bot, even though you do not have ground truth available. So, yeah.
Awesome. So now we've seen how we can measure it. We've seen this tool. We've ran our baseline. How do we solve this?
Yes. So let's remember the problem was we were saying, what's the temperature rating of the cozy night sleeping bag? That came back perfectly.
Right.
And then we said, what's the temperature rating of my sleeping bag? And that did not come back with like, it was kind of looking up other sleeping bags, but right. Yeah. So, and the reason is that when we actually go and look up documents from the document, from the cognitive search, Azure AI search, I should say, we are only asking for that very query that user gave in, right? But that does just say my sleeping bag, and since cognitive search doesn't know, the cognitive search does not have the same context that ChatGPT has. So what we need to do is we need to rewrite that query, the user query, to be more comprehensive and contain more context about what is actually being looked for, right? So we need to basically turn what's my sleeping, like what's the temperature rating of my sleeping bag, we need to turn that into what's the temperature rating of the cozy night sleeping bag. Okay, and I have a separate, where am I here, come on. I have a separate folder for that, which is now this RAG flow folder, and I already made that change, so we don't have to watch me kind of type this up. Let's look at the prompt flow. What you can see here is that we just added one additional node here in the prompt flow, which is this rewrite query node. And if I click on that, you can see it's a Python function. And this Python function takes in the query that the user had, the chat history, like what was said before in that conversation, and then the customer data. So that information that says, OK, I'm Jason Brown, and these are all my orders, right? And what we're doing here then is we're actually, in this case, we're actually calling ChatGPT directly. So first, we're kind of applying this Jinja template here using just the Jinja library. And then we're actually directly using the OpenAI API. We could also just call the REST API. We can do, this is just Python code. You can do whatever you want in prompt flow, right? It's up to you. And so, yeah, if I just show you real quick the template that's doing the work. It's going to be like, you see a pattern emerge here. You're an AI assistant reading the transcript of a conversation between a user and an assistant. And in this case, we're actually not using GPT-4 because in the production flow, we do not want to take the expensive model in this case. Maybe with 𝗀𝗲𝗸𝗀, that's going to be a different matter. But GPT-4 is expensive and slow. And so here, this is just something that is just fine for ChatGPT or GPT 3.5. So again, we've been giving a few short examples here. This one is, what if the user had like an order history with a supercamper 2-person tent, and this was asking like, what is the waterproof rating of the tent, and then the intent, which is kind of the value to return, would be the user would like to know the waterproof rating of the supercamper 2-person tent they bought. Okay, so.
Cool. I love that the answer to our question is more AI. It's like, how do we do this? We add more AI in, actually. Yeah.
Yes. Yeah, and in order to get productive with these, that's often the answer.
Right.
Okay, so shall we kind of run it and see whether that actually did the trick? So now we need to activate our treatment, which just means that we're just not calling this baseline flow. Now we're calling this other flow. We're just going to a different directory. And then we're going to ask that question, what is the temperature rating of my sleeping bag? Bag. I have like a cuddly bat.
A cuddly bat.
It's a sleeping bat. Okay.
There it goes. It worked.
It worked. Thank you. Yay. Okay, and if we dig like one little bit deeper, we can actually see that this time the citations actually returned cozy night sleeping bags, so that's awesome. And also the query rewrite has actually worked, so that was the output of this one node that we had there that we created. The user would like to know the temperature rating of their cozy night sleeping bag. So yeah, so that's kind of it.
This also reminds me of one of my favorite quotes, which I think is very relevant for LLMs, is the question you ask dictates the answer you get.
Yes.
Pretty much prompt engineering, right?
Exactly.
Summed up. Okay, cool. So we've seen how to fix it. I think we should run another batch run and see how good this is working by leveraging the AI Studio.
Yeah, and that I would do like another batch run here, kick off the same script for pointing to a different folder, obviously. Again, we already did that before, so that we don't have to wait for it. And so here's our second run. You can see it's the treatment evaluation. And I can like look at it individually. You can already see like the grounded is actually up quite a bit, but maybe you didn't remember what it was before. And so let's compare them side by side. And here we can see that the groundedness before was 347, now it's 394, so that's an increase of almost 0.5. So if you just have an increasement of like 100 or like so, there's some variation to these models as you see, and even also to the evaluations, even with temperature to 0. But generally, like a bump in that kind of order of magnitude is definitely something that is a real change. And the relevance is also up by quite a lot. So it's not only is it more grounded, but it's also actually giving answers that are more or better actually answering what the user was asking for. So I think that's it, right?
That's it. Let's go back and see what I get to deploy now, right?
Exactly. Let's look at our flow here. Yeah. So we're done with number 2. Strictly speaking, we would, of course, like test more and have multiple data sets and also have like a larger data set for overall testing and so on. But, I think you would understand more of the same.
Yep.
And now we'll kind of bring it over to operationalization.
Amazing. So the first thing I want to show you is that we have the new AI CLI. And if I do AI help, we can actually take a look at some of the different features I have in it. I can init a new project in AI Studio. I can use the chat to do an interactive chat. And I can also use prompt flow with the prompt flow part of it. So here you can see I can create a new prompt flow. I can create a local server to test it out. I can package and deploy. So one thing I actually want to show you quickly is that you can do AI chat interactive. And then I can actually test out a model right here in my UI. So I can ask it that same question again, and I can test out different scenarios right here within it. So that's super cool. I can deploy, I can do all kinds of things. It's awesome. Now I'm going to jump over back to AI Studio. And if you remember, we saw some of the deployments that we used from pre-built models. I'm now going to take a look at the prompt flow that I want to deploy. So I've already now pushed it up into the cloud, and I can go ahead and select it. So here you can see this looks just like the code first experience, but this is going to show us it in the cloud. We can share it with different people, collaborate with people, and you can see the file structure is exactly the same here. Then when we're ready to deploy this, we can click deploy. So I'm just going to use the UI to deploy it. I can give it an endpoint name, a deployment name, select my compute instance, and then click review and create. Now, because that takes a little while, I'm going to flip over to my deployments here, and I'm going to select a deployment that I've already created. So when you create this deployment, it's going to look very similar to what you've seen when you create any sort of resource. We can go in and we can actually test it and make sure that my deployment is working after it was deployed. Let's see. Oh, it actually answered it. OK.
But it calls you Emily Rodriguez, so and the emojis as well that we asked for.
And then here you can see I gave it the customer ID, so it thinks I'm Emily today. OK, and then from here we can take a look at how to consume it. We have some different sample code that we can use. And then we have something really cool here called monitoring. So in order to use this, you literally just click enable on the deployed endpoint. And now I can start getting metrics of how my model is continuing to perform well in production. And if we take a look a little bit deeper into the kind of insight we're getting, so as you can see, these are those same metrics we were using locally. I also can take a look between latest runs, and I can go through and take a look at different days and see how different things are performing. And if we take a look into how it was performing, so we get a notification in our inbox that there was an issue that you might want to look at. And you can click into that and then get more information. So here you can see they asked, what is the best pair of shoes I can buy? Now, if you remember, our agent was told to just support previous orders. It wasn't really told how to help with people making a purchase. So it seems to me like we might want to add an additional layer and have an intent classification that would route either to the sales assistant prompt flow or the support assistant prompt flow. So this is giving me some feedback about how it's performing and how customers are actually using this. And then I can decide if it's something I need to update with my model, if it's maybe something I don't want to fix, or in this case, I need to add another layer into my solution. We can take a look at the relevance one, and you can see we had one that said testing, and it just said, how can I help? That's probably not an issue I'm really concerned about, so I'm going to go ahead and ignore that one. But now we're able to go do the whole end-to-end thing. We were able to deploy, create our application. And let's actually go back to that beautiful diagram.
Oops, that one.
Yeah, there we go. So now you can see we went from end to end. We have created our prompt flow. We had our business case. We connected our data. We ran it and evaluated it. We found an issue. We learned how to solve it. We deployed it, and then we're able to monitor it in production.
Awesome. So let's bring Jithendra back up. Thank you.
Good job, guys. All right, that was a great demo. You saw the power of the platform, all the way starting from a model catalog to how you work with the models, to actually work with vector databases, and eventually deploy the model as well. And we spent a lot of energy pulling these capabilities together into an integrated platform. Especially evaluation is very important. We spent a lot of energy on it, and hopefully you saw that coming through in our demos as well. And we're happy to share that our prompt flow, which is our core of our evaluation capability, is GA now in Azure Machine Learning, and soon to be, it's in public preview in Azure AI Studio. And our model catalog, which you saw in the beginning, and how Cassie started with picking different models, that's soon to be GA as well. We have a lot of great models there already, but our work is not done. We're continually looking to see how to bring the best of the models from top-tier industry providers. And the way we thought about the platform and built the platform means that you get to abstract some of the latest innovation going on in the large language models. So you get to actually experiment with the newer models and even evaluate and replace the older models with the new models. And this is something we do constantly at our own copilots at Microsoft. And the vector search, I'm also happy to share that vector search in our Azure AI Search is also generally available. Not all vector databases are created equal. As you saw in the demo that Cassie and Daniel just showed, what you give as input to the models matters a lot in how relevant the results are. And relevance, that means that the relevance of what you retrieve in response to customer's query actually matters a lot. We took years of work, great work that's done in Bing, and combined that with our vector database work so that you get the benefit of the best relevant results that actually can be given as input to your application so that your AI application is of the highest quality. But we're not done yet. We're going to continue to innovate. If you're interested in learning more, please join our Azure ML Insiders program. And we'll get access to latest innovation going on, and you get to experiment with some of the new feature work we're doing. And finally, please check out our hero offerings. It's a great place for you to see how you can start on fast-track your AI generative application journey. Finally, on behalf of entire Azure AI platform, thank you for joining our session, and have a great rest of the day.